Welcome back to section 2 of chapter 9. In this section we are going to continue solving quadratic equations, but now we're going to use a much more algebraic way, which is by factoring. Now this will still only get us nice answers, really. It's not going to get us, like, there are some answers that this is not going to be effective in getting us, but it is a good stepping stone, and it is the easiest, quickest way of solving quadratics if you can do it by factoring. Our learning targets: I can find a solution of a quadratic equation by factoring. So how does this work? We're going to use what's called the zero product property. Well, the zero product property says that if something times something equals 0, then either A equals 0 or B equals 0. Because if you have two things multiplied together equaling 0, one of those two things has to equal 0. That's the only way for it to work. That is not true if you have two things multiplied together to be any other number. So it is important that they have to equal 0. So what does this look like? If we have a factored quadratic, say x minus 9 times 5x plus 2 equals 0, that means either x minus 9 equals 0 or 5x plus 2 equals 0. If x minus 9 equals 0, we can add 9 to both sides and get that x equals 9. 5x plus 2 equals 0, we can subtract 2. So 5x equals negative 2, divide both sides by 5 to get x equals negative 2/5. So there would be our two answers. If it was a situation where you'd only have one answer, both the factors would be the same. We'd have like x minus 9 times x minus 9. And if there were 0 answers, we wouldn't have been able to factor it at all. We'll see how to deal with that in the next section. But when we factor it, we can split it up into two linear equations, which we've been solving since the very beginning of this year. So the big step comes with factoring. Remember factoring, so the very first thing we're going to need to do is we're going to need to set this equal to 0, not negative 20. So we need to add 20 to both sides. So we get x squared plus 9x plus 20 equals 0. Now when we're factoring, we're going to have something times something, something times something equals 0. What times what equals x squared? That's x times x. Now we need two numbers that multiply to give us 20 that add to give us 9. What times what equals 20? Well, there's 20 times 1. That's not going to add up to give us 9. We have 2 times 10. That adds up to give us 12. That's closer. 4 times 5. 4 times 5 adds up to get us 9. So we have plus 4 and plus 5. If you need to refresh your factoring, that was back in chapter 7. So we have x plus 4 times x plus 5 equals 0. We have something times something equals 0. That means either x plus 4 equals 0 or x plus 5 equals 0. We can subtract 4 from this one to get x equals negative 4, or we can subtract 5, x equals negative 5. There's our two solutions. We can do it with a application problem. We set these up last chapter. A museum vault has an outer steel wall with a uniform width of x. It shows us in our picture. The area of the museum vault ceiling with the outer steel wall is 1,664 square feet. What is the width of the outer steel wall? So we need to find x. So we can set it up. We have 20 plus 2x here. And we have 40 plus 2x here. And so the area would be 20 plus 2x times 40 plus 2x. And that area, it tells us, is equal to 1,664 square feet. Now, the mistake people make here is they see like, hey, this is already factored. And so either 20 plus 2x equals 1664 or 40 plus 2x equals 1664. No, remember it has to equal 0. So it is factored right now, but we can't actually use that. We have to multiply this out. So remember, to multiply it out, we're going to take everything here and multiply it to everything over there. So we have 20 times 40 is going to be 800. 20 times 2x is plus 40x. 2x times 40 is plus 80x. 2x times 2x is plus 4x squared equals 1664. Now we can subtract that 1664 from both sides. And let's also rearrange it. Let's start out with our x squared. So we have 4x squared. And then we have some x's. We have 40x plus 80x, so that's plus 120x. And then we have 800 minus 1664 is negative 864 equals 0. So we're going to factor this first step of factoring, factor out what they have in common. These are all even. More than that, they're all divisible by 4. So we can take a 4 out of here, which will make it easier. Oop, that equals 0, not x. So we'll have x squared plus 30x minus 216. And so we can factor this. So we'll have an x and an x. We'll have to have a plus and a minus because a positive and negative will multiply to give us 216. And then those two things will have to add together, which will look like subtraction to get to that 30. So what times what equals 216? Well, there's 216 and 1, but that's going to subtract to 215. There's 108 and 2. That's still a ways off. There's 216s divisible by 3, which would be 72 times 3. Still not going to subtract to give us 30. 30 is not, or 4. 54 times 4 is going to give us 216. Still not going to make it. That'll give us 50. It's not divisible by 5. It is divisible by 6, however, and that would be 36. We can get it to 30 with a 36 and a 6. Specifically, if the 36 is positive and the 6 is negative. Now we'd have x squared minus 6x plus 36x gives us plus 30x minus 216. Now to solve this, we have something times something equals 0. We actually have 3 things multiplied equals 0 because we have 4 times x plus 36 times x minus 6 equals 0. So x minus 6 could equal 0, or x plus 36 could equal 0, or 4 could equal 0. But we don't need to think about that because 4 does not equal 0. 4 equals 4. So if x plus 36 equals 0, we can subtract 36 minus 36. We get x equals negative 36. Or here we can add 6. We get x equals 6. So the wall is either negative 36 feet thick or 6 feet thick. Which one of those makes sense? Right. The wall is 6 feet thick. The negative 36 doesn't make sense because it's negative. it would also make it completely backwards. We can use the factored form to help us graph as well. So we have f of x equals x squared minus 2x minus 8. We can factor this. We'll have x and x. We need two things that multiply to give us 8, that add to give us a 2, but being that one's positive, one's negative, they'll subtract to give us a 2. 4 and 2. Which one has to be negative to get a negative 2? The bigger one. So we have x plus 2 and x minus 4, which if we wanted to find out when these equal 0, either x plus 2 equals 0 or x minus 4 equals 0. If x plus 2 equals 0, we can subtract 2 to get x equals negative 2. X minus 4, we can add 4 to get x equals 4. So those are our zeros, negative 2 and 4. We can find the vertex. Remember, the vertex is at negative b over 2a, so we have negative 2 over 2 times 1, which negative 2 is 2, divided by 2 is just 1. We can plug that in to find the y value. So 1 squared is 1, minus 2 minus 8 is going to be negative 9. So our vertex will be at the point 1 comma negative 9. And then we have our zeros, which were negative 2 comma 0 and 4 comma 0. So we can use those to help us graph. So we have 1 negative 9, and then negative 2 0, 4 0, and we can graph. We didn't have to make a table and find a bunch of other points. We could have, we could find the y-intercept. It's just negative 8, which means we'd also have negative 8 right over here. My points miraculously went right where they were supposed to there. I think even, no, the next ones didn't. But we can factor it to help us graph, because that gives us the zeros. Those zeros are great points to graph from. So if we have the vertex and 2 zeros, we can sketch our graph. And then we can also write the factored form of a quadratic from a graph. So here we have negative 5 and 1. If we have x equals negative 5, what would be the factor that gives us that? Well, we'd have to add 5 to both sides. X plus 5 would equal 0. If x equals 1, that means we could subtract 1 to have the factor x minus 1 equals 0. So we have both of those factors. And so we could have f of x equals x plus 5 times x minus 1. That will be a quadratic that goes through those 2 points. However, there could be vertical stretch or compression. We do not know. So we're going to put an a in there. And then we have to plug in a point to find that value. There's a lot of points we could plug in. We could plug in the vertex. One of my favorite points, what we cannot plug in is we cannot plug in one of the zeros that we used. However, the y-intercept here at negative 5, when x equals 0, y equals negative 5, let's plug that in. Negative 5 equals a times 0 plus 5 times 0 minus 1. So this is negative 5 equals a times 5 times negative 1. Isn't that just negative 5? So let's divide by negative 5 to get negative 5. That's 1 equals a. So f of x equals 1, which we don't need to write, times x plus 5 times x minus 1. If, say, a equaled 2, we would just put a 2 in front of this. That's the factored form of the quadratic. And we can get it straight from these points. We don't have to do anything really weird or anything like that. We just go from the zeros, turn them back into factors, and then plug in a point to find out what that a value is going to be. So we'll be working on this in class, and I'll see you then. Until then, keep working problems, keep asking questions, and as always, happy mathing.